I'm going to quickly solve this problem. I have already partially solved it here on this YouTube lecture, but over there I have gone also through marginal revenue and marginal cost, and also the lecture is a little bit long. I'm going to solve it again. So I'll go to this Excel sheet. I open the Excel sheet object, information regarding demand curve, and I have information regarding the total cost. I copy this part, this is my total cost, and file, new, I go here and paste it. And I also go back to my demand curve and I copy it here, Excel sheet, and paste it over there, and then I'll go and close the previous one. So I have some data about my total based on the quantity produced and my price based on the quantity sold. And we assume that quantity sold and quantity produced are equal. Whatever we have produced, we have sold, and whatever we have sold, we produce. But the data that we have it available here, they are not for the same quantities. These quantities are different. They are not for the same quantities, but they show the general relationship between cost and quantity and price and quantity. So this is what I have. If I go here and insert and go to scatter graph and draw something there like this, this is my total cost, and I can go here, mark this part, and insert scatter graph, and so here is my total cost, and here is my demand curve, which shows the relationship between price and quantity and total cost. And now we want to fit a line to this total cost, fit a line here and a line here. That is our objective. These points will not be exactly on the line, but the purpose of the line that we draw, and we all want to be on the same page, is to minimize the average of the gaps between the actual data that we have observed and the numbers that we have found using these lines. I have F, which is my fixed cost, and that would be equal to intercept of these costs and these production volumes. And therefore, my fixed cost is 1200. Okay. Now I go here and type variable cost and equal to slope of these numbers versus these numbers. So I found my variable cost and I found my fixed cost. And my total cost, the equation for my total cost is equal to fixed cost plus variable cost times quantity. That is the equation of the line. I type P max, and that is intercept of the demand curve with the y-axis, which shows the maximum price that I can sell this product for. And that is equal to intercept, comma, enter 175. Slope of the line is equal to slope of these numbers and these numbers, and that is slope of my price curve. Therefore, my price is defined as Pmax plus slope times Q, or P is equal to 175 minus 2.5 Q. That is my price. And after I define price, total revenue is equal to price times quantity. I have everything. And the maximum that I can sell, P, is equal to 175 minus 2.5 Q. If I set price equal to 0, then 175 will be equal to 2.5 Q. Q is 175 divided by 2.5. Q max, what is the maximum that I can sell? And that is equal to 175 divided by negative of negative 2.5, because 2.5 was negative on one side of the equation. I brought it to the other side, it becomes positive. So I'll go here. First, I define my Q, quantity. Then I go down and I define P. So if this is Q and we don't know how much it is, then P will be equal to P max, this is P, plus slope multiplied by Q, and that is my price. If this is quantity, this is price. Now if I enter 1, price will go down. If I enter 70, price will become 0, because we realize that even if we set price equal to 0, we can sell only 70 units. Therefore, total revenue is equal to price multiplied by quantity. Now if I'm at this point and I want to find a price which maximizes my total revenue, I cannot use solver for price because price has a formula in it. I should use it for quantity, but as soon as I find the best quantity, the best price will be automatically identified. So I go to data, I go to solver, and I say, Mr. Solver, please maximize, not minimize, not set equal to something, but maximize this total revenue, which is here, by doing what? By changing the quantity. Solved, problem is solved, and the quantity of 35, which leads to price of 87.5, and indeed that is price of 87.5, which leads to quantity of 35, will provide me the maximum revenue. Then I come here, I have my fixed cost, and that fixed cost is equal to this fixed cost, and then variable cost. I just need to copy this down. That one was 1200. If I copy it down, this one will be also copied over there. Total cost is equal to fixed cost plus variable cost multiplied by quantity, and that is my total cost. Now I come here and I define total profit, which is simply equal to total revenue minus total cost. Now I go back to solver, but this time, instead of looking at total revenue, please look at total profit. Again, still change that cell B25, which is my quantity. Solve, I get 31.8, and maximum profit is this. Therefore, 31.8 is the point of profit maximization. The price is 95.5. It will lead to quantity of 31.8, and that is the quantity and price that maximize my profit. Now let me do something here. I go here and I define Q here, and I define P here. I'll go here and type 0. I go to this corner, right click, come down, go back, leave it series, fill series. With a step of 1, the maximum quantity that I can sell is 70, and I want to go in a column, not in a row. Okay, so these numbers are filled for me. Quantities from 0 to 70. Okay, and I know that the relationship between price and quantity was max price, which is this, and I like it now because I'm going to copy it down, plus slope, which was this one, and I like it because I'm going to copy it down, multiplied by Q. I cannot click on A34, I click on 35 and then go up. So that is the relationship between price and quantity. And at price of 0, quantity is equal to 70. Now I am going to hide this to make my job a little bit easier. Hide. Then I come here, mark this 2 column, insert scatter graph, and I wanna draw this graph. The graph looks a little bit strange because it doesn't show the cells that I have hidden here. So I'll go to this point, select data. I will go here, empty cells, show data in hidden cells. Okay, now that is the relationship between quantity and price. At price of 175, we sell nothing, and if I set the price equal to 0, I sell 70 units. Go here and turn this price into total revenue. Total revenue, this is price. I put parentheses around it. This is my price. Revenue is price multiplied by quantity. Enter, copy it down. So this is the relationship between quantity and total revenue. At quantity of 0, total revenue is 0, it goes up and then comes down. Your economic professors, your microeconomic professors has explained it to you in your lower division course. Now I want to turn this total revenue curve into total profit. The first thing I should do, I should subtract the fixed cost from these values, and my fixed cost is here. That is my fixed cost, and then I copy it down. So that is, oops, I forgot to lock this. I should lock it because I'm going to copy it down. So that is my total revenue minus fixed cost. But it is not enough. I should also subtract the variable cost. So I go and put a parenthesis before fixed cost, which negative sign is over there, plus variable cost, which is here. Don't forget to lock it because you want to copy it down, multiplied by the quantity that I am producing. And that quantity is here. And then I close the parenthesis and enter it and copy it down. This is my total profit curve. As you see, profit goes from negative to zero, reaches a maximum, and then comes down again. Now I want to find these 2 points. When I use solver, it may give me this one, or it may give me this one. How do I know if it's this one or this one? I go up for the quantity that maximizes my profit. If what Excel give me is less than 31.8, that is this point. If it is greater than 31.8, it is this point, because at 31.8, the profit is maximized. I go to data, I go to solver. I say, Mr. Solver, again, I want you to look at my profit. Again, I want you to change it by looking at quantity. But this time, I don't want you to maximize it or minimize it. I want to set it equal to a value, and that value is 0, which has been typed over there for you automatically. What I can do, I solve and I get 54. So at 54.84, my total profit is very close to 0. So, but when I compare 54 with 31.8, I realize that the point that I have found is here, the larger one. And now I need to find this one. How I find this one? I know it is less than 31.8. So again, I will go to solver. I say, solver, do the same thing, but add a constraint. The value that you put it here, I want it to be less than or equal to this one. The value that you find, I want to be less than or equal to this one, but I want the objective function to be 0. Okay, solve. Excel solve it, and it find the other one. So this one and the other one, we found both of them. If it had found this one, which was equal to this, and then I copy it and paste it by value to have it over there. If it was this, I will go back to solver, data, solver. I delete this one, delete, and again everything is like before, but this time I add a constraint and I say, Mr. Excel, I want this one not to be less than or equal, but to be greater than equal to this one, which was the point of profit maximization, and that is okay, and that is okay, therefore equal to this one. I found the other one. The point of profit maximization is 31.8. The first break-even point is 8.75, and the second one, the larger, is 54. Solvers sometimes find this one first, sometimes find the other one first. If it finds this one first, I should say my quantity should be greater than or equal to this, because this is below this one. I want to find one which is greater than that one. If it finds this quantity, should be less than or equal to this one, and then it will find this one. I hope you have followed me. I have explained this several times in class, and I thought if I create a very short video that may help you. Thank you very much for your attention. Thank you very much for trying to help us to provide you a better education. Better education is not possible with more and more time from the professor. Better education, more than anything else, is affected by your effective, relative, scheduled availability. Scheduled availability is the time that you allocate to your education on campus or anywhere off campus. Relative scheduled availability is scheduled availability divided by unit load, the number of units that you have taken. So the number of hours that you allocate to your education, the number of units that you have taken, that is relative scheduled availability, but it will go nowhere if in class you are not focused. Therefore, I define the level of your focus in class as net availability, and net availability is multiplied by relative scheduled availability to create effective relative scheduled availability. Because no matter how much time do you assign to your education, how much time do you allocate to your education, if you are not 100% focused, you will not get the best result. Thank you again, and I wish you good luck.